This is actually the perfect day for this because it's kind of gusty and blustery outside. So today we're going to talk about wind. This is 6.3 of the Earth and Space Notes. Wind is the motion of gas particles from areas of high pressure to areas of low pressure. And we already talked quite a bit about what creates high pressure and low pressure areas. It mostly comes down to temperature. Where it's warm, it's higher pressure, and where it's cold, it's low pressure because of the way it affects the density of the air. And so the two major factors then that create wind patterns around the world, the global wind patterns, are the difference between the equatorial and polar temperatures. The cooler area is a high pressure zone and warm area is a low pressure zone. And so the higher the difference, the more substantial the change in temperature, the stronger the wind. The other factor is the Coriolis effect. Basically, we know that the Earth is turning. Whoops. Go back up. We know that the Earth is turning underneath the atmosphere. When the wind is blowing, it's trying to go in a straight line, but the Earth is rotating underneath it. And so this gives it a turn. It's moving towards, it pushes it towards the right or towards the left, depending on which hemisphere it's in. This is apparent curving of the wind due to Earth's rotation. It sounds odd to think that the slow turn of the Earth could affect the way the wind blows, but on a global scale it does. And we even see it on other planets as well, like Jupiter and Saturn and stuff like that. So this creates a right-hand swirly turn in the northern hemisphere and a left-hand turn in the southern hemisphere. Okay, so these global wind patterns. Here's a diagram showing them. They're very predictable depending on latitude and which hemisphere you're in. So starting at the equator, and then we'll move from there. Along the equator, there's an area that has very little wind. This is called the doldrums. It's sort of windless and rainy there. There's no Coriolis effect right at the equator because that straight line is a straight line as the Earth turns. And so the air rises up vertically. There's very little horizontal motion. Then as it goes higher up, it gets colder, and so it condenses into clouds and rain falls. Very, very little wind at all. This is why doldrums can also be synonymous for almost like depression. If you're in the doldrums, you're kind of stuck in a rut. You're not doing anything and nothing's changing. It was sort of feared by sailors for a long time because as they sailed their ships across the equator, they could literally get stuck. There'd be places where there was so little wind that the ship itself just kind of stopped. You know, it didn't have any wind to fill its sails, and it just got stuck there at the equator until a storm blew through or something like that. The doldrums were feared because you could get stuck at sea. Okay, as you move away from that, we have what are called the trade winds, above and below, from about the equator to 30 degrees latitude. These are also known as easterlies because they blow from the east towards the west, and they're moving down towards the equator. So it goes you sort of east to west and down. So these are also called the tropical easterlies. They're known as the trade winds because this is the winds that were most widely used by trade delegations. So if, for example, you're traveling from Europe to North America, like Christopher Columbus did, you'd want to stay in the tropical easterlies because it's blowing towards the west, and we were traveling west. While you were on your way, that's one of the reasons why he discovered like the Caribbean islands first instead of discovering Vermont first, because he was right there above the equator in these easterlies. And then when you're going back to Europe, when you're traveling east again, you'd actually want to go further up and get into what's called the prevailing westerlies, between 30 degrees to 60 degrees. It blows from the west, and so you get up higher, you know, further away from the equator. The wind would change direction, start blowing west, and you can more easily get back to Europe. So the trade winds were used a lot for traveling. So were the westerlies too, and knowing which way the winds were blowing would help a lot with your ships. Where we live is in the middle of these prevailing westerlies. This is why most of our storms blow in from the west and are heading east, because that's the motion of the air right above us. And then finally, when you get high enough, closer to the poles, above 60-degree latitude, you get the polar easterlies. There's dense, cold air that sinks down and away from the poles. It's blowing from the east to the west. Okay, some other patterns that are important. High up in the atmosphere are the jet streams. Jet streams are narrow bands of super fast air. We're talking hurricane speeds. The jet stream itself kind of is rotating and wrapped around itself. So the outermost edges might be about 80 miles per hour, but in the middle, it's getting up to 140 miles per hour at the center of the jet stream. very, very fast-moving bands of air. These occur at the boundaries between cold, dry polar air and the tropical air, and they get stronger and faster in the winter, and as they kind of do this sort of tumbling pattern, up and down, rising and falling around the globe, it can cause really dramatic changes in our weather. You might remember about 5 years ago, we had a super cold winter. There was a stretch in January for about 3 weeks that was below zero. That's because this polar jet stream dipped way far south that year, and it dragged all this Arctic air down from Canada and the North Pole all the way down here to Kansas, and then it just stuck there for weeks, and we were freezing. But then it went back to normal. Some years it does it, some years it doesn't. It's hard to predict, but it can cause huge changes in the weather. So we keep an eye on those jet streams. There's a subtropical jet stream as well, closer to the equator, that helps control some of that wetter, warmer tropical air. Okay, and then measuring wind speeds, we use what's called the Beaufort scale, where we can just sort of describe it in terms of meters per second or miles per hour. We're all familiar with these nice calm ones, but like storms, violent storms, and hurricanes are down here. Keep in mind, this doesn't even touch tornadoes. Tornadoes are a whole other classification. Tornadoes can get up to 200, 300 miles per hour. They're ridiculously strong. We're going to talk about a whole day just about tornadoes. So this is our Beaufort scale. Okay, that's it for the notes for today. I hope you have a good day. Get out there and enjoy some of this weather. Bye.